Hi, this is Kona, and I know it says probability in-class assignment, but just consider this, a probability assignment. Ignore that. So I'm just going to talk through how to find these answers. So how many ways can you divide a class of 4 groups into 3 students each? So if you remember from our notes, the formula for that is our total number, which we've got 4 groups times 3 students. We're looking for our total number. So that's 4 times 3 is 12. So we take our total number divided by our 3, which is our number of students, factorial, raised to the power, which is the number of groups. And if you do that one out, so, hold on. So if we do 12 factorial divided by 3, factorial, raised to the power of 4, and we get 369,600. So our next one, how many ways can you divide a sample into groups of 4 men and 5 women? This is different because we've got number of groups. This isn't the same because it's not 4 groups into groups of 4 men and 5 women. So our total number is 9 people in each group. So there's our 9 factorial. And then we're dividing it by the total number from option A times the total number for option B, and those are factorials. So you've got 9 factorial, 9 factorial divided by 4 factorial times 5 factorial equals 126. So there's the answer for that one. Okay, if 16.7% of people smoke and 3 people are randomly selected, what is the probability that all smoke? All right, so we're not given a lot of information, and this is where the table becomes really, really important. So here's how we do our table. Smoke, yes or no, and the probability. So probability they smoke is 0.167. So the probability they wouldn't smoke is 0.88833. And that was found by doing 1 minus the 0.167, because remember these have to add to 1. And then for our number, so what's the probability that all smoke? Well, that would be our 3 here, a 0 here, and then a 3 down there. So if we go back to our formula, we'd have a 3 factorial, and that's this 3 right here, divided by 3 factorial, that's this one, times 0 factorial, and that's this one. And we're multiplying it by our probability taken to the number, so 0.167 to the 3rd power times 0.833 taken to the 0 power. So we know this 0 becomes a 1, so 3 factorial divided by 3 factorial is just 1. And then 0.833 to the 0 power is 1. So basically, the only one that we're really worried about right here is the 0.167 raised to the 3rd power. And that gives us this 0.004657,463 right there. So that's where we get that answer. All right. So moving right along, on the probability, it's really small. 0.004 is the probability there. All right, so if 36% of people think global warming is the most important issue, 14% think the federal deficit, and the rest think it's something else. All right, so we've got 36, 14, and the rest think something else. So if 10 people are chosen at random, what's the probability that at least one will say global warming is the most important issue? Okay, well that's an at least. Remember the at least ones? Those are the ones where instead of doing everything like the 1 and 10 and the 2 and 9 and 3 and 7, we're going to do 0 and 10. So, but the question is, where do we get our numbers from? And this is going to be really similar to something you'll see on the quiz. So draw your table. Please, please do your table. So our issue is global warming, federal deficit, and something else. So we know 36% think global warming, 14% the federal deficit. And what's that something else? Well, if we do our 1 minus 0.36 minus 0.14, we get 0.50. Then for our number, we know we're going to say that 0, think global warming. What's the probability that at least 1 will say global warming? Well, that's where instead of 1, we use the 0 for global warming and the 10 for these two right here. Because it doesn't matter which one, we can group them all together. So instead of using these two individually, this is where we put it together, use 0.64 and 10. So that's where that 0.64, I just added these two together, because for this specific problem, we don't have to do them individually. We can add them together, which is really nice. So then we use our total n divided by 0 factorial times 10 factorial times the 0.36 taken to the 0 power times the 0.64 taken to the 10th power. Well, if you remember, once again with the at least, this type of problem, that's equal to 1. 0.36 to the 0 power is equal to 1. So we just get left with 0.64 raised to the 10th power, which is equal to the 0.1115. Okay, but remember, we have to subtract the 1 because it's an at least problem. So we do 1 actually minus 0.64 raised to the 10th. And we get 0.988470785. Okay, so here, and these are more that'll be like on the quiz, if 68% of people like chocolate, then what does this probability tell you? And so we're given this, so 68% of people like chocolate, what does this probability tell you? Well, how many people were surveyed? Well, remember, this number is our total n. So when we see this on the quiz, they're going to give you a statement probably like this, or they'll just give you this formula. And you have to take this formula and figure out from the formula how to answer these questions. So how many people were surveyed? Well, 15, because we know our total n is that top number. So the 15, which comes from the 15 factorial. How many people don't like chocolate? Well, we know that 68% of people like chocolate, so that means we know 0.32 people, or 0.32% don't like chocolate, and we know this 10 refers to the number of people then that don't like chocolate. So 10, which comes from the 0.32 and this 10 right here. So if they want to know the number of people who like chocolate, that would be 5 because it's 0.68 raised to the 5th. If they want to know the percent of people who don't like chocolate, that would be the 0.32. So there's lots of information you can get from this formula and a little bit of information, and those are kind of the easy questions because you can just look at it and answer it. But I hope this helps, and let me know if you have any questions.